Welcome to session 4 of Hypermesh Radio's interface demos, and I'm Prashanth from Alter Engineering India. In this session, I'll be showing the demo on contacts. So contacts which I'm basically discussing here will be type 7 and type 11 contact. So both are penalty based contact. The type 7 is our global contact, which you can define for the complete assembly. So this is a contact between node to surfaces, and you can define between surface to surface also. And this is basically is our global contact. Okay, whereas type 7 cannot address edge to edge. So if you have to define a contact between edge to edge or edge to surface, then you have to use type 11 contact. So I'll be showing how to create these two contacts using Hypermesh. So let's move to the tools. If you recall in the previous session where we were discussing on the creation of loads and boundary conditions. So there I created the model in two directions. Like I created one model for running it as an impact case where the loading is initial velocity, gravity, and I have the rigid walls. And I created one more model where the loading was imposed displacement and I had some boundary conditions. Okay, so at the end of the session, I'll be showing the results for these two cases also. But now to move further, I'll be taking the quasi-static case because whatever I'll be doing for this case, they will be applicable even for the impact case also. Okay, so since I don't want to do any repetition here, so I'll be taking the quasi-static model, whereas what all the things which I do it here, the creation of contact and going further, the output request, the way I create the engines, files, so they all are applicable even for the impact case also. Okay, so let's take the quasi-static model. Okay, so this is the model where we did the setup of quasi-static analysis. Okay, fine. Okay, so here, yeah, this is a quasi-static case, and we are applying the imposed displacement, and so we have constrained this vehicle in the axles, front and rear axles, but we have the suspension as well. Okay, so normally in these type of like roof cases, we normally lock the suspension, but I have not done anything like that. I have just left them open. So in the result, you may see that even the suspension also working when I apply the roof load. Okay, so those are all the things which we will see when we see the results, and I'll explain more regarding that one. Okay. Now specifically regarding this today's in this session, it is type 7 creation. Before jumping into the contact, one important thing what you have to keep in mind is when you build the model for radios, and from the contact working perspective, you have to make sure that the contacts are free from intersections. Okay, so there is a difference between intersection and penetration. Penetration is attributed to the thickness, the virtual thickness, which you don't see, but it is coming from the property. But whereas the intersection is physically crossing over of elements, which you can see when you go to that region, you can physically see that elements are going inside one another, and that is not okay. Okay, so you have to make sure the models are free from intersections. So let's see that how this model is. So I will go to tools, penetration. So I'm checking all the intersections. And thickness, I'm taking 80% of property thickness. So let me select all the components and check it. Okay. Uh, yeah, I found some intersections, maybe at some local location. Okay, and there are some penetrations. Penetration, I have a method to deal with it. That I will manage it in the contact. But as much as possible, I don't want to have any intersections. So let me see where it is. It is just one very local region. If you recall, here we have even the tide contact also. So from the working wise, it should not create many problems, but I just want to keep my model clean. So let me clear this intersection. Okay, fine. Okay, so this is done. So I will just recheck again. Okay, again I have to select the thing. So let me check it again. Okay, I don't have an intersection and I have some penetrations. So as I was telling, like I'll use some of the options by which I can deal with some of the small penetration, but you should ensure that you don't have much deeper penetration in terms of thickness. Okay, so this is the first step. Of course, this is a step what you have to ensure after completing your model building itself. But since the relevance is in the contact, I am touching this point here. Okay. The first thing is I have to create a global contact, which is a type 7. So in the event of loading or in the event of impact, in the case of impact case, we expect that any component can come in contact with any component. Okay. So you can create one big global contact by including all the components. Okay. It's a self contact. So now I'll be creating a separate contact between this impactor and the structure. So as of now, I will just mask this one. Okay. And also it's a good practice and a suggested thing to keep only the 2D and 3D elements. So I will say isolate 2D. Okay. And I will add 3D. So now I have only 2D and 3D components here. So now I'll create the contact. So I will say create contact. So I will say it as global, and this will be my type 7 contact. So I have to select the master and slave. So in this case, so all the components will be the master for me and all the components will be the slave. It's a self contact. So I'm going with component. Okay, here I want to show you one option. So for that reason, maybe what I will do is let me unselect this part. Okay, so this is like one common thing. Okay, I'm still in this option. Okay, so maybe this option I'll be able to show you only once I complete export and come back. See, at this stage, it has not yet written the parameters which are required for the deck. In the sense, like when I select the components, in the background when I'm exporting the file, it will be written as the group node part, and here the surface part. So group node part will be for the slave, and surface part will be for the master. So now what I wanted to show you is, see, in this case it is 10 components, and if I have missed something, I can always come back here and I can add the components. So it was 167, now it is 168. So it is easier to update if you have missed anything. Okay, but now let's say if you have done the activity, if you have exported the file, and again if you come back, the representation here will be no more like components. So here it will be shown as the set IDs. Okay, so then in that scenario, like we will give you, like there will be an option here. You can go and you can edit that set. Okay, so you'll get one more pop-up window. So through that you can directly add the components. Okay, so that is possible. So that is true. That will be used in many of the instances. Like now, let's say you have applied the initial velocity and you have forgotten some of the nodes or components. You can do that. The same thing applies with the loads and boundary conditions also. Okay, so that is fine. And here the other things, now I created the contact between the whole bodies, but sometimes you may be having a specific interest that you want to create the contact between some two parts or between few elements. Yes, it is possible. There are different options. So this is for slave, and you can go with the different options to create the contact at a local region also. So those are the things which are possible. You can create it, and you can update also. So why I'm telling specifically this one, because earlier we had some challenges in especially editing the entities after creating it. So creation is simpler, but when you come to editing, there were some challenges. So now it is quite easy and robust, where even after creating and exporting the file, when you bring back it, it is quite handy to edit all these entities. Okay, fine. So I have selected the master and slave. Now I'm using some of our recommended parameter for the contact, which is like IST4. I'm going with a specific gap option with F scale as 0.8. So again, these are the parameters which we go quite in detail in our trainings. What are the relevance of these parameters and how they are working. And I will go with a minimum gap also here. And I'll specify inact is very important parameter, since I have some of the penetration also. So this is the parameter which is going to take care of those penetration. So I should not forget to put this one, since I have penetration also here. So I'm putting inact as 6, and I will use iform 2, and I have to put the friction. Okay, so these are the entities what I have to put for type 7. So now if I review, yeah, it will show the entire thing as master and slave both. So if you remember, like we have also created a type 7 between these two. So but that doesn't matter, you can have both type 2 and type 7 in the same location. And type 2, what we created for this seat also is a contact, but it is a kinematic contact, and what we are creating now, it is a penalty based contact, basically sliding contacts. Okay, so we created type 7 successfully, good. Now the next task is I have to create type 11. Okay, so I just want to create a type 11 between this surface and this tube. This I can make it to work using type 7 also. This is it's a surface to surface contact, and this can work well with type 7 of course. But just to have the variety and just to show the demo of how to create the type 11. So I'm taking this region. I have a curved surface and a flat plate, so maybe like type 11 will work more efficiently than type 7. That is one reason. Okay. So for type, okay, now I'll choose the component in which I have to create this type 11. Okay, fine. So here I have to be careful. For type 11, it's a contact between line segment and a line segment. Okay, so here it is little bit workaround because we don't have the direct method of creating the line segments here. So I'm using one of the workaround where I'll be creating the line segments, and those line segments I'll be using it in the type 11 contact. Okay, so before that I just need one dummy collector. So let me create it, and I'll name it as maybe a dummy. Fine. Okay. Now I know that, yeah, so this is, I hope I'm correct. Okay, I'm correct. Yeah. So now just observe the procedure. So what I'm doing here is I'm creating the duplicates of some elements which I feel will come in contact. Okay. So you can go with any option. I'm going with the mask. You can go with any options where it will give you an option to duplicate the elements. So I'm saying duplicate, and I'm using current collector. Okay. So now we have duplicate elements over there, and I will equivalence them also. Okay, so I'll just take these elements, and I'm keeping some very low tolerance because elements are anyway lying there only. Preview equivalence, of course it will show equivalence for all, and I will say equivalence. Okay, so now I have created equivalence. The reason for that is now after doing like that, now I'll go for finding the edges. Okay, so you have the options to find the edges. So here, of course, if you find now the free edges, you will find the plotted elements in this location, but I will switch it to T connections, and I will say find edges, so which will find the edges all over here. Okay, so these are the plotted elements, or these are the line elements which I'll be using to create line segment. Okay, so because I have to create one more line segment, so let me move it to an separate collector here. Okay, because in the edges, if you create the new edges, the old edges will get deleted. So for that reason, I'm just moving it to a new name. So now same thing I have to do for the impactor. So I'll go with some option, element, duplicate. Okay, current component, return. So now we have duplicate. So preview equivalent. So all those regions, and I'll say equivalent. And now I'll take the component and I will say okay, now if I say edges, it will create the edges even for this because here also we have the same component. So I'll go with maybe elements. Okay, T connections. So find edges. Okay, now I have them there. Okay, so all this activity was to create the line segments, which we already got now. So now I don't need this dummy collector, so I can delete it. So before that, let me create the line segments. Okay. So now here where you can create the line segments. So I can go to analysis. I can go to contact surfaces, and let me name. Okay, I already have a name. Slave. So elements by collector. Okay, so this is the one which was the first one that I will use it as slave, and this is also one of the good point to keep in mind. So when you have two surfaces and when you have to make one as master and one as slave, it is normally a question like which have to be the master and which have to be the slave. So the generic people will go with many guidelines depending on the materials, depending on the load application member. So there are many guidelines which you might have come across. But the one guideline which is important from the radio's context is you have to always make the coarse mesh as the master and the fine mesh as the slave. So that works good. Okay, so here the fine mesh is this, so that I'm going with the slave. I'm creating that. So I'll make master. Again, new one. Okay, it's created. So now I have all the ingredients ready for creating the type 11, and I will delete this. Yes. Okay. Don't delete the edges. Anyway, it will not be exported. We have the cap. Okay, but if you delete the edges, the segments are associated with that edges. So don't delete the edges. Uh, you can just leave that in the model. Okay. So now I'll come to the contact creation. So create contact. So this time it will be type 11. Okay, so now for so here as you can see it is not giving you all the options to pick as it was doing it in type 7 because this takes only the contact surfaces, and if you have already created a set, of course you can call it. Now for slave I will pick the slave segment, and for master I'll pick the master segment, and I will use the same parameters even here. Okay, again enact. I may have penetration or I may not have penetration in this, especially the contact between these two. I'm sure that I don't have any penetration, but still it is advisable to use this enact 6 as a standard option. And normally in the edge contact we don't define any friction, but this is not pure edge to edge, so I may define a friction. Otherwise in the pure edge to edge contact we don't define friction. Okay, so yeah, that is for just let me name it is impact to body. Okay, so let me review this. So if you review, you can see the master and slave like this. Okay, so it's good till here. Okay, so we have one global contact and one local contact here. But as I was telling, like at this region, you can as well create the regular type 7 also. And if you want, you can put still everything also in one contact. Okay, and for the impact case, of course, we don't have this member, so I'll be just creating one uh, global contact for the vehicle. That is enough. Okay, and between road and the tires, I have already the R wall. It's a kinematic condition, and I have the same thing for the barrier also. So I don't. Apart from one global type 7, I don't require anything for the impact case. So this is the end of session 4. So in the next session, I'll be demoing some of the other entities like the monitored volume and others. Thank you.